replacing b by x0. So I will drop the 0. So negative f of x0 over x1 minus x0 equals f prime of x0. I will cross multiply. 1 times this equals this times this. I'm dividing by f prime. And adding x0 to both sides. Okay, stay with me because I'm gonna just show you one more step, and then you'll tell me what I should do next. I'm happy with x1, but I want a better approximation. I will repeat the process. I will draw a vertical line. It crosses the graph in this point. I'm going to draw the tangent. It will cross the x-axis in a point x2, which is definitely closer to r than x1 was and much closer to r than x0 was. So I'm looking for x2. When I get x2, I repeat the process. I draw a vertical line, a tangent. A tangent will cross the x-axis into point x3, and x3 is definitely a closer point, a better approximation, on and on and on. So, can anyone give us, after we find x1, the first iteration, the second iteration? Can anyone give us, without calculations, the second iteration? Maybe even the third, and then the general one.
Is it xn is equal to xn minus 1?
Yes. So let's write the x2 for everyone to see, and then we'll write the rest.
So equals x1 minus f x1 over f prime of x1.
Of course, this is x2 minus f of x2 over f prime of x2, and indeed the previous one minus f of the previous one over f prime of the previous one. This is Newton's method. Exactly. Two problems. And this is one that I came across right here. By trying to enlarge, and I curved the function too much, and I would have gotten in trouble with this one. So meaning, what I'm saying is, if there is a max or a min between the root and your starting point, look what happens. Okay, so you may get in trouble in the sense that initially you may go away from the root instead of getting closer and closer, and if there is a max or a min between the starting point and the root, the method will not converge. That's one possible problem. The second possible problem is here. You have to make sure that you do not choose a starting point that creates f prime 0. So if I choose 1 to start with, but f prime of 1 is 0, I will not be able to solve. I will never get to the solution. So two potential problems. Make sure that you start in such a way that there is no max min between the starting point and the solution, because the method will not converge. That's one potential problem. The second potential problem is when you start with a value that makes f prime 0, you will not even be able to find the first iteration. So careful with that. Let's look at a problem and see how this works. And now you know everything in chapter 4. So Okay, so let's say problem 18 on 342. And we have the square root of x plus 1 equals x squared minus x. Let me not choose this one because this is not that difficult to solve algebraically. It's possible. You can square both sides. Yeah, never mind. I copied it, so that's it. That's okay. It doesn't matter. Okay, in the first step, I have to create a function by moving everything to one side. The square root of x plus 1 minus x squared plus x equals 0. And this is the function that we are talking about. It is a continuous function on x greater than or equal to -1. Careful, here I can plug in anything I want, but here I have to have x plus 1 greater than or equal to 0. So because we will have to use an interval, we have to find the interval. Okay, number 2, we plug it in the calculator to find an interval where there is a solution. So in y equals, clear, the square root of x plus 1, and then minus x squared, and then plus x, and go to the table and start plugging in some numbers starting with -1. -1, 0, I'm done. There is a solution between -1 and 0. Because at -1 the function is negative and at 1 the function is positive. That's all I needed. By the intermediate value theorem, between -1 and 0, this is all I need. I will find f prime, 1 over 2 the square root of x plus 1 minus 2x plus 1. I will write Newton's method with x0 minus f of x over the derivative and we have to decide how to start. If I start with 0, I'm fine. If I start with -1, I'm not fine. I can't start with -1. Careful. The derivative doesn't even exist. So I will say I choose x0 to be 0. Let's put in this function in the graphing calculator. Be careful with parentheses. The entire function as you see it. So go to y equals. I'm not going to clear because this is the numerator of that function. So I'm just going to insert x and subtract, put parentheses around the numerator, go to the very end and put parentheses again. I didn't want to delete it because I already had that. So I wrote x minus that over this, divided by, in parentheses, careful with this, 1 divided by, in parentheses, 2 the square root of x plus 1. Close the parenthesis for the denominator. I did not put enough parentheses. And close the parenthesis for the denominator. And then minus 2x and plus 1. Oops, plus 1. And close the parenthesis. Once you put that in, second and quit and go to variables. I will do this many times. I just want to finish this problem so I can show you what it is or what are the steps. I'm calling the function y1. In parentheses I want to put 0 because I'm evaluating all this for x equals 0. And I get this number. I go back and copy. But this time instead of 0 I want to put in the previous answer. And press enter. So I found x1. We haven't established how many decimal digits. Let's say 6 digits. So negative 0.123456 x2 is negative 0.4998327. No, I'm sorry, 2971. I repeat, inserting the previous number all the time back into the function. I have x3 equals negative 0.48415265. I know I copied more than that. I'll show you, I'll explain why. So x4, the fourth iteration, 48402831, and x5, negative 0.48402830. So I see that 6 digits now are repeating. So there is no need for this one. The solution, the real solution, with 1, 2, 3, 4, 5, 6 decimal digits is negative 0.484028.